I'm Mr. B, your automotive professor for today. So today we're going to be talking about refrigeration cycle, okay, which is very important in use on cars in their air conditioning system. So we're going to go over the refrigeration cycle, some do's and some don'ts, some of the components of this type of system plus another system I'm going to touch on a little bit later. And we're going to try to get just the basics down of this system and give you a little bit better understanding of how it works so you can go into your diagnostics a little bit more effective. So let's talk about the system that I have here drawn on the board. Guys, I'm not a very good artist, but I did the best I could here. This is a TXV style system. It's on about 70% of the vehicles that you'll see in a shop in North America. TXV is going to stand for thermal expansion valve. Okay, sometimes this is called an expansion valve, TXV valve, thermal valve. Anyway, that is going to be the restriction in the system. So we're going to need a restriction, okay? And the TXV valve is going to be that restriction. We also have our compressor. Compressors are on any type of system. It can be belt driven or it can be electronically driven if you have a hybrid or a plug-in electric vehicle. We're going to have a condenser right here that's going to be mounted in front of the vehicle, normally in front of the radiator. So air gets through the grill and is able to heat soak this down and get it cooled off. We're going to have some type of dryer, either receiver dryer or an evaporator if you have an Orifice Tube style system. And of course you're going to have an evaporator which is going to provide the cooling effect to the car that we get on the inside of the vehicle. So it's pretty important, and I try to tell all my students to remember that this system is not cooling the air inside the vehicle. It is removing heat from the air. Okay, and once you understand this, is going to make this a little bit easier to comprehend. So you have two types of sides in a refrigerant system. You have a high side, which is normally notated in the red, and then you have what we call a low side, which is normally notated in blue. So a lot of my students kind of think of this as power and ground. And so the high side would be the power since it comes out of the compressor, and the ground, of course, would be the low side since it goes into the compressor here. And it's important to remember that it goes high side to low side. Okay, the system would not work properly if it ran backwards. So let's talk a little bit about what's going on in the high side and low side. So your compressor here is compressing the refrigerant, whatever refrigerant that you're using, at a very high pressure. And so pressure and temperature are, you know, like peas and carrots, they're hand in hand. So when the refrigerant leaves the compressor, it is a high temperature, high pressure vapor, okay? So vapor or gas, some people like to call it a gas. So as this is leaving here, the car is on, the AC compressor is engaged, the clutch is engaged, therefore leaving the compressor to start pumping. So we're taking this high pressure, high temperature gas and we're going to transport this into the condenser. Okay, now the condenser is a very important part of the system because this is what actually removes the heat from the refrigerant. Okay? So remember that we're not cooling the car down, we're actually cooling the evaporator down, okay? And we're sucking in the heat with the evaporator and bringing it back to the compressor to start the whole system. Let's not get ahead of ourselves. So we have a high temperature, high pressure gas going into the condenser, and the condenser does what its namesake is saying it's supposed to do. It condenses this high temperature, high pressure gas into a liquid, okay? It condenses it, just like the condensation on the outside of your Coke can or anything else. And so this is going to fall down and be a high temperature, high pressure liquid, okay? Now, the condenser's up front because it has to get a good amount of airflow for that condensation situation to happen. So this is why we have fans, and if we have an air-conditioned car, we may have extra fans on the front of the vehicle to cool this condenser down as well. So now we have a liquid coming out of the condenser, we're supposed to, right? So we are going to come down here to the dryer, okay? The main job of the dryer is, again, in its name, it's going to make sure there is no moisture, liquid, water, humidity, anything like that in this, and it's going to catch it here. And it has a bag, what we call a desiccant, inside. So if you've ever bought a pair of tennis shoes, furniture, sometimes really nice box shirts and everything, they'll have that little bag of silica gel on the bottom. Remember, it says do not eat silica gel on it. I'm pretty sure everybody's already seen one of those. But we have a large bag in there, sometimes it's called a sock, that's in this dryer, and the refrigerant passes over it, and any moisture that's in this refrigerant will get dried in the dryer or get trapped in that sock. Okay? Moisture in the system's bad. It can cause a buildup of acid. It can also freeze in the system and freeze up the system and possibly damage the compressor as well. So we want this is why we put a vacuum on the system when we're doing a recharge or anything like that. We want to get all the moisture out of the system, but if there's any left over, the dryer will take care of it. So now we have high temperature, high pressure liquid. Okay? We're going to take this over to our thermal expansion valve. Okay? So the thermal expansion valve, what it's going to do is, again, in its name, this is why I like AC components. They pretty much do what they're named. So it's pretty easy to remember. So the thermal expansion valve is going to take that liquid and expand it, okay, or add volume to this liquid. So when we add volume, our pressure is going to reduce, okay? So when we reduce the pressure, this liquid is going to turn to a high pressure gas spraying out, just like the nozzle on a spray paint can or anything like that. It's going to spray out, and it's going to drop temperature very quickly because we're expanding this. It's going to drop temperature. If you've ever had a can of computer cleaner or anything in your hand and you're using it for a long time and you notice that the can is getting cold in your hand, that's exactly how this system works. Okay? So we're spraying this refrigerant into the evaporator. Now the TXV is what I call a gateway. Okay? The gateway is called a gateway because it's the gateway between the high and the low side of the system. So when we meet the TXV valve, we go to low side. Okay? In a different system, this would be the Orifice Tube. If you have a domestic style system, the Orifice Tube would be your controlled restriction that allows that refrigerant to go from that high pressure, high temperature liquid to a low pressure, low temperature gas. So as this low temperature, low pressure gas is cycling in this evaporator, your blower motor inside the vehicle is taking all that hot air and it's blowing over the evaporator. Now we know through law of thermodynamics that the temperature will move from hot to cold. Okay, that's why when we put our frying pan on the stove, it takes a while for the handle to get hot. Eventually will, but it moves from hot to cold. So the heat that's all in the cabin of this vehicle is going to get pushed into this evaporator. Okay, and the evaporator is going to take that heat and it's going to put it, again, we should at this point be all low temperature gas. And if you feel the low side on your vehicle, it'll only be the bigger round side hose that you have or line, then it'll be cold, okay? And it's going to take all this heat and it's going to dump it into the compressor and the cycle starts over again. So that heat will be, again, transferred to the ambient air through the condenser. So, again, very important thing, you have your two gateways here, you have your TXV valve, and you have your compressor. And that's the difference between your high side and your low side. So your restriction and your primary moving compressor here is going to be your gateways. Everything in between. So let's go over the parts again. So your condenser, your dryer is going to be on the high side. Your TXV valve is considered kind of a hybrid. Half of it's high side, half of it's low side. Also important to remember, the TXV valve can control how much refrigerant is being sprayed into the evaporator. That way we don't get the evaporator to freeze up. We don't want the evaporator to get too cold because this condensation that's coming off of there can actually freeze and cause airflow not to pass through the evaporator. So this is going to make sure it's not too hot, not too cold, and adjust the orifice or the hole that's letting the refrigerant into the evaporator. Okay. So as this comes back around, this is going to go back into the compressor, which is considered a gateway. It's neither a high side or a low side part. It's a gateway. And the cycle is going to continue again. Okay? So there's some misconceptions about refrigeration systems. Okay? And you'll see this a lot if you've ever tried to buy a used car or older vehicle or something like that. They'll say, air conditioning works, just have to top up the Freon, okay? So that means that there's a leak in the system, okay? These systems do not consume any refrigerant, okay? This compressor does not eat it, it does not dry up. The only way for a system to be low is if it was one, undercharged in the first place, or two, it's got a leak. 90% of the time it's going to have a leak, okay? So remember with this system that it's pretty easy once you get this down to diagnose it, okay? So if our gauge readings are showing something crazy, we can narrow it down to what side it is and start our diagnostics from there. So knowing how this system works, knowing how it plays out inside the vehicle. Also, the great thing about this is whether you have a Yugo or a Bugatti, it's going to work almost exactly the same. The control side might be different. You might have an automatic air conditioner or an automatic climate control, but the core of this system, the refrigeration cycle, is going to work the same. Okay, so that's all I have for you in this video. If you have any questions, please just drop them in the comments, and I will do what I can to get them answered to you. And also, please like and subscribe so I can generate some more of these videos for you guys. I really am enjoying this, and it's pretty fun. So hope you're having fun, hope you're learning something, and I'll see you next time.